Hi, I'm Ms. Roger, and welcome back to Core Concepts in Algebra 2. Today's lesson is on rational expressions. Let's take a look at today's lesson objectives. To simplify rational expressions, to multiply and divide rational expressions, and to add and subtract rational expressions. Let's take a look at the definition of a rational expression. A rational expression is the quotient of two polynomials. It is helpful to think about rational expressions as ratios, as fractions, or as quotients. A rational expression is in simplest form when its numerator and denominator are polynomials that have no common divisors. Let's take a look at our first problem. Simplify each rational expression and state any restrictions on the variables. So when I examine a problem like this, I have a quadratic in the numerator and a linear binomial in the denominator. So I want to say to myself, how can I simplify this? How can I break it down? If I think about the factors of x squared minus 15x plus 54, this might help me start to simplify and reduce this. So if I think about the factors that multiply together to give me this quadratic, I'm going to get x minus 6 and x minus 9. And all I'm doing here is I'm just rewriting it to look a little bit differently, so then if I can simplify or reduce, then that allows me to. Clearly you see an x minus 9 and an x minus 9 in the numerator and the denominator, which is going to allow me to cancel those out. So my final answer here, my simplified version, is going to be x minus 6. When it starts to ask, think about the restrictions on the variables. This is specifically for x minus 9, the value that's in the denominator. So I want to think about what this can't be. And when I have a value of 0 in the denominator, that's when this is going to be undefined. So I can think about this, if I set this expression equal to 0 and solve, I can then say x can't equal 9. So this would be a restriction. Let's take a look at our second problem. 9r squared minus 72r all over r minus 8. So again, we want to think about what strategies we can use to simplify this. And one of the strategies is going to be either to factor a polynomial. So in the numerator, if I factor out a 9r, I'm going to have 9r parentheses r minus 8. If I pull out or factor out a 9r. In the denominator, I'm going to have an r minus 8. And as you can see, those are going to cancel out, which actually works out very nicely. And my final answer is going to be 9r. Again, with restrictions to the domain, I want to think about when this denominator is going to equal 0. So r cannot equal 8. Let's take a look at a problem where we multiply two rational expressions together. So again, I want to use the technique, if I can, factoring. So when I think about n squared plus 7n minus 8, if I were to factor this, and it's a quadratic, so we should feel pretty comfortable doing that, this is going to be n plus 8 and n minus 1. And that does work. We have n minus 9 in the denominator here, so if you notice, this n minus 9 and n minus 9 will cancel out, cross-canceling. And if I think to myself, can I factor something out here, I can factor out a 4. So I can rewrite this to be represented as 4 parentheses n plus 8. And if you notice here, we have an n plus 8 and an n plus 8, and I can cross-cancel, that's my choice, or I can rewrite this and look at the numerators, look at the denominators, and cancel. So however you kind of see fit, work it out that way. If you can cross-cancel, I think that way kind of works out nicely, but then you have to account for everything. So what I have left in the numerator is n minus 1. And what I have left in the denominator is going to be a 4. So this is my final answer. I can't simplify or reduce this anymore. And again, I want to think about restrictions on the variables. So if I look at both denominators, I'm going to have n can't equal 9 and n can't equal negative 8. Let's take a look at another problem where we're multiplying two rational expressions. So we have a quadratic in the numerator of the first rational expression. Let's rewrite that in factored form. That's going to be n minus 7 and n plus 9. So as you can see, this n minus 7 and this n minus 7 are going to cancel out. And again, I can rewrite this, so let me show you the technique of rewriting it instead of cross-canceling. If I just want to rewrite this before I cancel anything out so I can clearly see what's happening, and again, I can put my 1 there. I have a 2n times n minus 7. This is technically what it looks like if you were to think about this and compare this to our work with fractions as well. Now you can clearly see that n minus 7 is going to cancel out. So the final answer is going to be n plus 9 all over 2n. Think about the restrictions to the denominator. Set each of these equal to 0, solve. So x cannot equal 0. N cannot equal 0, and n cannot equal 7. Let's take a look at a problem where we're dividing two rational expressions. So if I'm thinking about dividing fractions, my method, or what I would do, is I would make this into a multiplication problem. And the way that I would do that is I would take my first fraction and keep it the same. And the way that I make it a multiplication problem is I take this second ratio and I multiply by the reciprocal. So the reciprocal is going to be 7n plus 35 all over 10n. Now I'm ready to keep working, and this is now a multiplication problem which we started to talk about last time. So if I want to think about the factors of these quadratics so I can start to simplify, n squared plus 13n plus 40 is going to factor to be n plus 8 and n plus 5. And I want to factor everything as much as possible first. 7n plus 35, I can factor out a 7 and think about this as 7 parentheses n plus 5. And now I can start to cancel stuff out and simplify and reduce. And if I want to rewrite this, that's my choice. So I am going to rewrite it and then start to cancel out. This is going to be n plus 8. And remember, when you multiply these, you can just multiply the numerators, multiply the denominators. So I have n plus 8 times 7 n plus 5 all over n plus 8, n plus 5, and 10n. So anything that will cancel out, at this time I do want to cancel them out. My n plus 8 and n plus 8 are going to cancel out. My n plus 5 and my n plus 5 are going to cancel out. So all I'm left with is 7 over 10n. This is my final simplified answer when I divide these two rational expressions. When I think about restrictions on the variables, I want to think about restrictions in the denominator of the original problems in the denominator and to the simplified version. So for this problem, I'm going to say that n cannot equal -8 and -5, as well as -5, and that's a duplicate. And for this problem, this denominator, n cannot equal 0. Let's take a look at another problem where we divide two rational expressions. So again, one of my first steps is going to be to change this to a multiplication problem and multiply by the reciprocal of the second fraction. So I'm going to rewrite it. 1 over k minus 6 times the reciprocal. K squared minus 10k plus 24 all over k plus 9. And again here, I want to factor anything that can be factored. So I want to think about k squared minus 10k plus 24, how that factors. This is going to factor to be k minus 6 and k minus 4. And again, I can rewrite it here, or I can just start to cross-cancel. That's really my choice. I'm going to cross-cancel, so this k minus 6 and k minus 6 are going to cancel out. And in the numerator, I'm left with 1 times k minus 4, which is just k minus 4. And in the denominator, k plus 9. Again, I want to think about restrictions on the variables, and when I think about this, I want to think about any time the denominator equals 0 throughout this process. So in the original two problems, in my next line here, throughout the whole entire process, simplified versions. So k cannot equal 6 from this denominator. From this denominator, k cannot equal 6 and 4. Again, this denominator is a repeat, but we have a new one here. K cannot equal -9, and that's the same there. Let's take a look at a problem where we add two rational expressions. So for this problem, we want to get common denominators before we can actually add. So our common denominator here would be b minus 2 and b plus 6. So a strategy that we can use in order to do this is to multiply each of these ratios by the value that it's missing. So in order to get a common denominator for the first one of b minus 2 and b plus 6, I need to multiply the numerator by b plus 6. So this is going to be 5b b plus 6. For this fraction, I need to get a common denominator again of b minus 2 and b plus 6. I already have a b plus 6, so I need to multiply this ratio by b minus 2 over b minus 2. So in the numerator, I'm going to have 3b times b minus 2. And this is a strategy that can be used in order to get common denominators. I want to leave both of these in factored form until the end because I may be able to cancel stuff out. For this problem right here, when I multiply this out, I'm going to get 5b squared. 5b times 6 is going to give me 30b. 3b times b is 3b squared. 3b times -2 is -6b. And now I can add like terms. Let's add 5b squared plus 3b squared is going to give us 8b squared. 30b plus -6b is going to give us 24b. And this is all over our common denominator, b minus 2 and b plus 6. At this point, I want to factor my numerator and see if I can simplify or reduce. So if I factor out an 8b, 8b times what's 8b squared? B. 8b times what's 24b? 3. And in our denominator again, we have b minus 2 and b plus 6. So at this point, I notice that nothing can be canceled out. So my final answer is going to be 8b squared plus 24b all over b minus 2 and b plus 6. And we may be talking about putting this into standard form, but for right now we can leave it as factors and we'll discuss this more tomorrow. Let's think about the restrictions on the variables. And again, this is when the denominator equals 0. So we cannot have b equal 2 and -6 for this problem. Let's take a look at an addition problem of rational expressions. P minus 6 all over p squared minus 25 plus p minus 4 all over p squared minus 25. If you notice, these already have common denominators. That's a great sign. So what we're going to do is we're going to add the numerators. P plus p is 2p. -6 plus -4 is -10. And this is going to be all over our common denominator, which is p squared minus 25. You may be thinking to yourself, hey, I can factor this. But let's try and factor both the numerator and the denominator and see if we can get anything to cancel out. So for our numerator, we can factor out a 2. 2 parentheses p minus 5. In the denominator, this is going to factor to be p plus 5 and p minus 5. Notice that your b term is missing from standard form. Now, if you look at the blue values, I can clearly see that p minus 5 and p minus 5 are going to cancel out. This means my final answer is 2 over p plus 5. Again, restrictions on the variables is going to be p cannot equal -5 and p cannot equal +5. Let's take a look at the essential questions from today's lesson. How is simplifying rational expressions similar to simplifying fractions? How is it different? Why is it important to consider restrictions on the variable of a rational function? Why is factoring used when simplifying rational expressions? And how can rational equations be used to solve real-world applications? Think about these essential questions tonight, and we will discuss them in more depth tomorrow. After watching today's video on rational expressions, try these. For problems 1 through 9, simplify each rational expression and state any restrictions on each of the variables. Thanks for joining me in Core Concepts to Algebra 2. See you next time.